So part E is asking us to evaluate the integral of 1 on 5 minus 2t plus t squared dt, and the limits are minus 1 to 1. I'm going to begin by completing the square for this denominator. So 5 minus 2t plus t squared, if I were to write this in terms of something squared, I'll write t, because t squared is t squared, which is what we want on the left hand side. I want to halve the coefficient of t, so that's 1, and if I put a negative here, this would expand to t squared, which is what we want on the other side, minus 2t, which is what we want, but it will introduce a 1, and so what we want is a 5, so I'm just going to add a 4, and so this can be equal to that. So I can rewrite this in terms of 4 plus 1 minus t in brackets squared. So it's still the same question. I haven't changed anything. The limits are still negative 1 to 1. Okay. The reason I changed it to this form is that I can relate it now to this integral here, the standard integral. 1 on a squared plus x squared dx equals to 1 on a tan inverse x on a. Okay. So before we continue, I want to change these limits and write them in terms of, I'm going to introduce a new variable, so let u equal to 1 minus t. So du would be minus dt. Okay, so du equals to minus dt, and so dt also equals to negative du. It's really important. Let t equal to negative 1. I'm going to calculate the limits in terms of u. So when t is negative 1, u is 1 minus negative 1, which is 2. And when t is 1, u is 1 minus 1, which is 0. Okay, so I'll just rub out the working out on the board so I have more room. Okay, so our equation here can be written as equaling to, in terms of u, it would be from 2 to 0, 4 plus u squared du. But since du is negative dt, and dt is negative du, this would be negative. Okay. So to get rid of this negative, I can just switch the limits from 0 to 2, and this becomes positive 1 on 4 plus u squared du, and that would equal to, using our standard integrals which I mentioned earlier, that would equal to a half tan inverse u on 2, the limits 0 to 2. So I'll just rub this bottom part out. Okay, so just a recap. I got this part here from this standard integral here. The integral of 1 on a squared plus x squared dx equals to 1 on a tan inverse x on a. Okay, so this would equal to, I'm going to bring the half outside, and so 2 on 2 minus tan inverse 0 on 2. So this equals to